Good morning, everyone. This is Dhruti from Sri Venkateswara College of Engineering, CSE AI Department, Bengaluru. Today, I will give a small presentation on hidden Markov model. So in short, we can call it as HMM. Let's move to the introduction. Introduction. Hidden Markov model, HMM in short. It is a statistical model that is used to describe the probabilistic relationship between a sequence of observations and a sequence of hidden states. It is often used in situations where the underlying system or process that generates the observations is unknown or hidden. Hence, it got the name hidden Markov model. So basically, it is a statistical model where we can tell the probabilistic relationship by getting the sequence of observations and the getting the sequence of hidden states, and we can use this system to generate the observations, and it is also known as hidden. So therefore it is called as hidden Markov model. It is used to predict future observations or classify sequences based on the underlying hidden process that generates the data. It tells that we can get the observations that which can be predicted in the future, or else we can classify the sequences. So based upon the processes that are hidden, which is going to generate the data. Then a HMM consists of two types of variables. So those are hidden states and observations. The hidden states are the underlying variables that generate the observed, not directly observable. The observations are the variables that are measured and observed. So this is about the introduction to hidden Markov model. Then prediction of the weather for the next day based on the current day's weathers using the hidden Markov model. This code is going to import the NumPy, Matplot library, Seaborn, and the HMMLearn library. As we know, NumPy is used to store the multidimensional arrays. Matplot library is used in order to plot the graphs, and with the HMM library. So we can see the code snippet. First, import the necessary libraries, which is a command line. Then we go to the next line. We use import numpy as np. So we are going to call the in the whole of the program, the numpy array can be used as np. So which is used to store the multidimensional arrays. Then we go to the second line, that is import matplot library dot pyplot as plt. So in order to plot the graph, we are going to take the matplot library, and that will be called as plt throughout the program. Then the third line, that is import cborn as sns. Then the fourth line, from HMMLearn you're going to import HMM. Then we'll move to the next slide. Then define the model parameters. In this example, the state space is defined as a state, which is a list of two possible weather conditions, sunny and rainy. The observation space is defined as observations, which is a list of two possible observations, dry and wet. So the number of hidden states and the number of observations are defined as constants. Here we can see that we get two possible weather conditions. They are the sunny and rainy, and these observations will be defined from a list of two possible observations, that is dry and wet. And the hidden states number and the observations will be defined as a constants. Then we go to Python code here. So first line is a command line. You are going to mention the state space. So states here are sunny and rainy. Then you're going to take a variable n states, and you're going to find the length of the states that is given by using the len function. Then you're going to print the number of hidden states. By print function, you're going to write the statement as number of hidden states and you're going to print n states. Then you're going to define the observation space. So the observations here is equal to dry and wet. Then you're going to find the length of these observation by taking a variable n observation and finding the length by using the length function of the observations. Then you're going to print as usual, then the number of observations and n observations. The start probabilities, transition probabilities, and emission probabilities are defined as arrays. The start probabilities represent the probabilities of starting in each of the hidden states. The transition probabilities represent the probabilities of transitioning from one hidden state to another. And the emission probabilities represent the probabilities of observing each of the outputs given a hidden state. The initial state distribution is defined as state probability, which is an array of probabilities that represent the probability of the first state being sunny or rainy. The state transition probabilities are defined as transition probability, which is a 2 cross 2 array representing the probability of transitioning from one state to another. The observation likelihoods are defined as emission probability, which is a 2 cross 2 array representing the probability of generating each observation from each state. Then we can look into the Python code here. First line is a comment line where it tells you're going to define the initial state distribution. So state probability, the variable, it will be equal to the array of 0.6, 0.4. So these are the values which will be taken. You're using the array here, so therefore you're going to take NP as I told in the previous. Then you're going to print the state probability as a state probability. Then you're going to define the state transition probabilities. So transition probabilities, which is equal to np dot array of 0.7, 0.3, 0.3 and 0.7. Then you're going to print the transition probabilities. Uh, uh, then you're going to define the observation likelihoods. So emission probability, so which is equal to the array, so 0.9 and 0.1, 0.2 and 0.8. Then you're going to print emission probability, that is the emission probability. Create an instance of the HMM model and set the model parameters. The HMM model is defined using the HMM categorical HMM class from the HMM Learn library. An instance of the categorical HMM class is created with the number of hidden states set to n hidden states, and the parameters of the model are set using the start prob and transmit and emission prob attributes to the state probabilities, transition probabilities, and emission probabilities respectively. We can look into the Python code here. So the model is equal to HMM dot categorical HMM of n components, which is equal to n states. Then model dot, you're going to start the probability, which is equal to the state probability. Then model dot transmit, which is equal to transition probability. Model dot emission probability, so which is equal to emission probability. Then define an observation sequence. A sequence of observations is defined as one-dimensional NumPy array. So the observed data is defined as observations sequence, which is a sequence of integers representing the corresponding observation in the observations list. Then we can see the Python code here. Observation sequence, which is equal to np dot array of, you're going to take the array of zeros and ones and you're going to write reshape of -1 to 1. Then you're going to ask for the observations sequence, and this is the output we can see in the right hand side. Predict the most likely sequence of hidden states. So the most likely sequence of hidden states is computed using the prediction method of the HMM model. So we can look into the Python code here. Hidden states is equal to model.predict of observation sequence. Then you're going to print the statement most likely hidden states for the hidden states. And you can look the output here. It is given the array of zeros and ones. These are the hidden states. Decode the observation sequence. The vertebrae algorithm is used to calculate the most likely sequence of hidden states that generated the observations using the decode method of the model. The method returns the log probability of the most likely sequence of hidden states and the sequence of hidden states itself. We can see the Python code here, log probability hidden states, which is equal to model.decode of observations sequence length is equal to len of observations sequence algorithm is equal to vertebrae. You're going to print the log probability, then you're going to print the statement most likely hidden states are, and you can also see the log probability and most likely hidden states output. Then you're going to plot the graph for the Python code. So that is SNS.setStyle, where you're going to set the white grid. Then plt.plot of hidden states minus O. Label is equal to hidden states. Then you're going to use plt.xlabel, that is the x-axis, plt.ylabel, y-axis, and plt.title, sunny or rainy, and plt.legend and plt.show to print. Thank you.